So today we are going to be talking about the transformations of all the parent functions. So before we do anything, I want to make sure we can review the parent functions, and you know which ones are which. So which one is this?
Linear.
A linear. And what is the function notation for a linear? X. F of x equals x. Try not to cheat.
Okay.
All right, next one. Which one is this?
Absolute value.
Absolute value. And what's the function notation for an absolute value?
Absolute value.
All right. What about that one?
Quadratic.
Quadratic. And what's the function notation? X squared. All right. What about that one? Oh, you can't see. Hold on. No. Cubic. Cubic. And what did you say back there? X cubed. Yeah, x cubed. X to the third. All right, ready for the next one?
Oh, that's right.
Good. It's a radical, an even radical, and specifically in this class, we are going to work with the square roots. Yep, it's square roots. Say it again.
Yeah, the cube.
Exponential.
You'll see. Hold on.
Irrational.
Okay. Go back up here. All right, what's that one?
What's your cube root?
Odd radical, specifically in this class. Cube root. What about that one?
Rational.
Rational. What's the function notation?
1 over x.
1 over x. Very good. X is on the bottom of your fraction.
Exponential.
Oh, wait, no. Exponential.
Exponential.
Yeah.
Exponential. And what is the function notation for it?
You have a negative in it?
Square root of
B.
F of x equals b.
b to x, right?
X. Yeah. The important thing is, where is the x in an exponential? In the exponent. Yeah. In the exponent. So x is in the exponent for an exponential. Yeah. Exactly. All right, and then the last one.
Log.
Log and the function notation. Yep.
Log bx.
Good. All right, so all my functions. Yay. All right. The next thing that we are going to review
I don't want it. It's pretty.
is the transformations. So for the transformations, I do have that poster that's over there above Briseda. If you ever get stuck or you forget. Also, parent functions are around the room. Exponent rules are back there. Inverse poster is over there. So when you're doing the DBA, if you get stuck, see if the posters can help you. My calculator poster is over there. That will help you. The absolute value bars is right there. How to get a decimal, greater than, less than sign, exponent.
Wait, so we're taking the DBA in here. It's not like 4 hours long.
Yeah. It's like a 12 to 15 question test, just like your regular
really?
test.
What?
Yeah. It's not long. Yeah. Okay.
Are we not gonna do like rational, exponential, and log?
We will. Those are going to be the next units we do. Your DBA just covers the transformations of them, though. And so you don't need to know anything else but the transformations. Does that make sense? Okay. Which is what this is, the transformations. The reason why I want to talk about this one more time is because we are going to review the B value, which is the one that we are a little unfamiliar with, probably. All right? Yeah. So hopefully the A, the C, and the D, y'all got down good. All right? That's the goal. Most of the time, I would say 70 to 80% of the time, that's all you see is the A, the C, or the D. Occasionally, the B value will pop up, though. All right. Yeah, the B one's kind of hard. But the A and C and D are the more important ones. So, first of all, if it's on the outside, so these two outside guys, what my translations are going to be vertical translations. All right. So outside stuff is vertical, inside stuff is horizontal. Because this guy is being added, that translation is up and down.
Yes, give us all the answers.
Not yet. So because it's being added, your translation is up and down. Because this guy is being multiplied, that's going to affect your kind of like slope number. All right, so it's either going to stretch or compress or reflect your function because it's being multiplied. Does that make sense?
Yes.
All right. I know it's vertical because it's on the outside. If it's bigger than 1, just cover it up with my hand. If it's bigger than 1, it's a stretch. If it's less than 1, what is it?
Compression.
A compression. And if it's negative, reflection over the X or the Y? The X. Very good.
Horizontal what?
All right, so now for the B value. The B value is the same thing, except now you have to think everything is opposite. All right, so everything is going to be opposite. So first of all, it's horizontal. If your A is bigger than 1, it's opposite.
Compression.
Because everything's opposite. So if it's bigger than 1, it's a compression.
Oh, because the compression is okay, yeah.
If it's less than 1,
It's a stretch.
it's a stretch. And if it's negative,
It's a reflection
against the Y.
over the Y. And then the C value is
Left or right?
left and right, and you think opposite.
I see what you mean.
My brain.
All right, so take a second, soak it in. The A and the B are the same thing. They're both being multiplied. One is vertical, one is horizontal. All right. Hopefully we have the A, the C, and the D down. If it's bigger than 1, you're stretching. If it's less than 1, you're compressing. If it's negative, you reflect over the X. For the inside, the horizontal, you have to think backwards. All right, you have to think backwards. So everything is backwards on the inside, even the left and right. Because remember, if it's negative, you're going right. If it's positive, you're going left. Right? So everything is backwards on the inside. So if you can remember that, that will help you a lot. Outside stuff is normal. Inside stuff is backwards. So if it's greater than 1, you're compressing on the inside. If it's less, you're stretching. And if it's negative, you reflect over the Y. Does that make sense? Once again, if you're taking the DBA and you get stuck or you brain fart, this exact thing is on my poster over there, which I will try to remember to move to the front of the room so more, you can see it better instead of it being in the corner. Okay?
Excuse me. Sorry.
Okay. All right, now I'll get the notes/worksheet out today. I'm going to do one of each of these problems, and then the rest of it is going to be for you to do. Yeah, it's not, so for the reviewing for the DBA, it's not going to be like notes and practice like we normally do, because I'm just finding random materials to review us. After the DBA, we'll start doing notes and practice like usual again. Does that make sense? Okay.
So we turn these in?
Yeah, I'm going to want this one. I'll give it back though. Huh? Yeah, prefer. Well, tomorrow with the sub, you can finish this one and the one I give you with the sub.
Wait, is it the sub?
I don't know who it is.
Oh, I like the
The guy with the dude with the tattoos.
I can't remember.
Hello.
You should get them.
I know I got him for a couple of my days. I just can't remember because it's tomorrow or not.
He's great.
Mr. Homer. I don't like the old lady.
Oh no, she got an attitude.
This
Let's
Lisa-
record it.
No,
Okay.
Oh my God,
I'm gonna
evidence.
get off of her.
Don't do
So
it.
what she
I love
did,
you.
she closed the door at the
She's
first
funny
door. I'm
to
like,
me.
ma'am, you
Don't
closed
do
the door.
this
She's
to
like,
me, period.
what's the point? I'll go close it anyways. I ain't playing anymore. I have
Okay.
to go forward. I'm just like,
Who is Miss Lisa?
This skinny woman.
with the Michael Kors scarf.
Not Miss Goosey. Is she short? I love that
She's on
woman.
Facebook.
Anyways, I don't know who your sub is tomorrow. Hopefully it's somebody that you like though. Focus back up here. Focus.
I got a referral right here, baby.
So, number 1, it says describe the transformations necessary to transform the graph of f of x, the solid line, into the that of g of x, the dashed line. So, the solid line here are your parent functions. Your parent functions always start at 0, 0, right? They start at the origin.
What?
All right, so that's why we use the origin to figure out how we get translated. So, from the origin, how did I get to this point right here? Left 3. I just want the transformations, so otherwise, yes, you would be right. So all I need is left 3. Okay, and then now for my A value, my kind of like slope number. Right, it reflects because it gets flipped upside down. So reflect over x axis. And then is it stretched or compressed at all? It's kind of like review.
Wait, it is moved.
Okay, wait, tell me again, did it get stretched or compressed at all?
Yes.
Are you sure?
No, it's the same.
It's the same, right?
I was looking at the wrong one.
Okay. Up 1 over 1, down 1 over 1. So it's still 1 and 1. All right, so it didn't get stretched or compressed. So these are the only translations. All right, jump down to number 3. We've done like 1,000 of these problems. We just need to describe the transformations. So the negative sign, what kind of transformation is that?
Reflection.
Over x or y?
X.
Good. Reflect over x-axis. What about the 3?
The other one.
Vertical stretch. Vertical because it's on the outside. Stretch because it's bigger than 1. And then the 1, is it on the inside or the outside?
Outside. So it's down one.
Yeah. On the outside because your root bar ends. So just careful there with the roots. So yes, down 1. All right, there are a couple mistakes on this next section here. First of all, I want to do a log. So number 6, turn it into log of x.
Wait, so if it doesn't tell you the b, because I know there's supposed to be like a base b. So that means that it's just the 1.
Actually, it's understood to be 10. We'll talk about it later. You don't need to worry about it. Yeah.
Understood to be 10. Thanks.
We'll talk about that when we do the log unit. You don't need to know that right now. To enter the restroom.
I didn't even know.
Many ads in multi.
This year? No, we have basically polynomials, which deals with cubics, rationals, and exponentials and logs we kind of do together. It's like they go together. You'll see when we do them. So like 3 more units. Okay,
We don't have 3 more units in Helen.
for these 2 guys, 6 and 8, I don't know what happened. Maybe when I downloaded it lost my fraction. But do you see how both of these are compressions?
Yeah.
All right, compressions are fractions, right?
Yeah.
So these should both be fractions. And that was just a mistake on the paper. I don't know what happened there.
Wait, but it's a horizontal compression, so it wouldn't be a fraction.
When you put it into the function, you'll switch it. So
Oh,
I'm
really?
gonna do number 7 because it's a horizontal, and I'll show you what I mean.
Okay.
All right, so I'm gonna do number 7 specifically because it's a horizontal, and so it's a b value, and so I want to show you what happens there. First of all, it says expand. Expand and stretch are the same thing. So if you want to turn that into the word stretch, you can. On the DBA, you'll see the word stretch. All right, so the DBA, the vocabulary they use is stretch and compression. But I don't know, this paper just happened to have expand instead. All right, so
Can you put the 2 in front of the
hold on. So these are, make sure you're paying attention because this part is where I think you're going to get confused. These are my translations, and I have to put it into my function. So I'm going to write my function, and I'm going to leave blanks for my A, B, C, and D spot. I don't know if I need to put a number in all of the blanks, but I'm going to leave blanks just in case. Now, like I said, hopefully the C and the D, the left, right, up, down, those things that we can do pretty easily up to this point. Right. So I'm going to do them first. So if it's going right 1, is that on the inside or the outside?
Inside.
Inside. And it's negative because you have to switch it.
Oh, it's going to be on the inside.
All right, so these are my absolute value bars.
Wait, the b value will go.
No, because it's
Hold on, don't do the B just yet.
right. Yeah. So do that. Yeah. So.
And then it'll be plus 3 on the outside.
Yes.
Good, and then the plus 3 on the outside.
Oh,
then it
but
says-
the factors
it says
it
stretch
says horizontally. Did you turn it into 1/2? Okay.
Okay, so wait, hold on. Don't do the B value just yet because I got to show you. First of all, because there's already stuff here on the inside, I have to make sure to put this in parentheses. All right, because your b value is timesing by everything on the inside. And if you notice when I do this stuff and on the poster back there, the x minus c is in parentheses. Does that make sense? When you have that b value, because it's multiplying by everything. So I put it in parentheses because I see that it's stretching horizontally, so I know I'm going to have a number in here. All right. Now, whenever you do something on the inside, it's always weird, right? It's always backwards. When you're talking about the left and the right, you think backwards. So if it's right, it's a negative. If it's left, it's positive. Does that make sense? So when we're talking about a number that we're multiplying, we also have to go do it backwards. So instead of it being 2, 1 over 2. You take the reciprocal. So when you're putting stuff on the inside for horizontal translations, it's always going to be backwards in some way. If you're multiplying for this b value, you're talking about the reciprocal. And then if you're talking about the c value, it's opposite sign. So if you're going right, you really put a minus sign. If you're going left, you put a plus sign. All right, so anything that you put on the inside, you have to do it backwards. Outside stays the same, right? Up 3, plus 3. Outside stays the same. Stuff that goes on the inside, though, you have to make sure that you flip it around in the correct way.
So it is 1 over 2.
Yeah.
Yeah, I had that.
You had that? Okay, good. All right. Flip it over on the back. Cross out 9. I don't like number 9. All right, 10, 11, and 12.
What is 12?
Yeah, I was just about to say the same thing.
12 is, it's an absolute value.
Oh, I get it. Never mind.
It's a V.
What's wrong?
It just looks.
It just looks weird. This is the parent. This is the transformed. All right. The directions say write g of x, the dashed line, in terms of f of x, the solid line. So what it wants you to do is to write it in function notation, which is this guy that I wrote down here. A times f b x minus c plus d. So I don't actually care that this is a cube root or that this is an absolute value or this is a rational. I just want to know the translations and put it in for my a, my b, my c, and my d. Does that make sense? All right, so I'm going to do, which one do you want me to do?
10. Oh, wait, actually,
Okay.
No, do 11.
11? Okay. I'm going to do 11.
Oh,
Can
that
you
was
do
easy,
2 of
though.
them?
No.
Okay.
I'll do 11. All right, so 11 is the rational. So we start at the origin, right? All the parent functions, we're going to start at the origin.
Oh, okay.
So I write g of x equals and then the rest, right? Or do you have to can you just write like that?
You can just write that. It's okay.
Okay.
All right, if you look at number 11, my function got shifted to where my asymptotes are now there and there. Right, do you see it?
Yes.
The asymptote line here, the imaginary asymptote line here.
It's too many lines.
It's a lot of lines. Yeah.
Is it on -1 too?
Yep.
Okay.
So your new origin, it goes from 0, 0. Your new origin is right here. So tell me.
Can you do it in a different color? I can't see.
Yeah.
Honey, yeah, then
Like hot pink.
here, do you need to use my highlight? No?
That just made it worse.
Sorry.
It looked better.
All right. So from my origin to get to my new point, I went. Yep, left 1. And I went up 2. So left 1, up 2.
Oh, you have to do that weird thing.
Looking at my little banana shaped things, have they been compressed or stretched or anything? Nope. So we don't have an a value, so we're good. So it's just left 1 and up 2. So now I need to put that into my function notation. So the 1, is that the a, the b, the c, or the d?
The C.
The c. And is it going to be a +1 or a -1? A +1. And the 2, is that the a, the b, the c, or the d?
The D, so +2.
So +2 on the outside. And that's all you have to do.
Look.
It's too much going on. I can't see.
Parentheses.
The 10 and 12 are a little bit easier to see.
Oh, then why should you go on the big ones?
So that's that. The
Asymptotes. Yeah.
Okay.
All right, go to 13. Almost done. So number 13 is kind of just putting it all together. So we are going to identify the parent function, and then we are going to write a new equation for the function that is given. So
Do you have to do it in the translation?
no, now it's just writing it as like a function.
Oh, the G, so you just write it like however it is?
Mm-hmm.
Okay.
All right, so first of all, absolute value is the absolute value of x. So there's my parent, right? All right, now I want to figure out how I'm translated. Girls in the back, are y'all paying attention? I sure hope so.
You went over
I sure hope it does.
Good, so to get from here to here, I went to the right 2. And is it being stretched or compressed?
Horizontally
So
I'm
get-
compressed. Horizontally compressed, I'm sorry.
no, you're right. It's horizontally stretched, but vertically compressed.
Yeah.
The vertical.
Oh, I'm thinking about the numbers. I'm sorry. Yes, horizontally stretched.
All right, but I just need to figure out the a value. I like doing the vertical one because it's how you would normally do slope. So you don't need to worry about the b value when you're writing these guys. Okay, so
would this be
1/3.
what'd you say?
Yeah, whatever.
1/3. Yeah. Because your number like slope, you went
over 3?
rise 1, run 3. So your a value is going to be 1/3. And then the 2, is that going on the inside or the outside? Inside, is it going to be a +2 or a -2?
Minus 2.
And you have the absolute value bars because it is a absolute value function.
He's number 14.
Get away now.
No.